Solutions for Quiz 8 for Math 251. All throughout this quiz, we'll be dealing with critical values, either finding them or classifying them. So in this first one, you're given a function and asked to find its critical values. So this function, you could rewrite as x to the 1/3 power times x plus 7, or I guess 7 plus x is the way it's written, squared. So when you're trying to find the derivative, which is what you need to find the critical values, you'll use the product rule. So the derivative of x to the 1/3 power using the power rule is 1/3 x to the negative 2/3. And then you leave the 7 plus x squared alone. And then add to that the derivative of 7 plus x squared, which is 2 times 7 plus x to the 1 power times the derivative of 7 plus x, which just happens to be 1, times first thing left alone, x to the 1/3 power. So you stare at this, and for critical values, you want to find out when this thing is undefined and when this thing equals 0. F prime of x is undefined if x equals 0. Why is that true? Well, really, it comes from this factor right here in this first term, this x to the negative 2/3 power. If x equals 0, this is 1 over x to the 2/3 power. So x to the 2/3 power, if x equals 0, is just 0. And so I got 1 over 0, that's undefined. So I get my first critical value if x equals 0. But we can also find critical values by setting f prime of x equal to 0. So here's my derivative, 1/3, this mess right here. You're going to try to set that equal to 0 and solve, but it's something plus something, which is kind of a pain to deal with. So I gave you a little bit of a hint. I said factor this thing out from your derivative. So if you factor out 7 plus x times x to the negative 2/3 from each of these two terms, here's my first term, here's my second term, what I'd have left over here, I'd still have the 1/3, and then x to the negative 2/3 I pulled out, and I had 7 plus x squared, I pulled one of them out, so I got 7 plus x left behind to the 1 power. And then from this second term, I still got the 2, I pulled out the 7 plus x, I had x to the 1/3, and I took out x to the negative 2/3. So 1/3 minus negative 2/3 is x to the 1 power. Which you can clean this up a little bit if you want. You got x to the negative 2/3, and then that is times 7 plus x, and that is times, well, let's see, I got 1/3 x plus 2 x's. So 1/3 x plus 2 more x's, I can think about that as 1/3 x plus 6/3 x. So I have 7/3 x plus, and then this 1/3 times this 7 gives me 7/3. You could factor out a 1/3 from each of those, or you could just leave things like this, because at this point, we'll kind of jump over here and figure out when this thing equals 0. Maybe I should switch colors. So I got x to the negative 2/3 could equal 0. This entire thing equals 0 if this first factor equals 0, or the second factor equals 0, or the third factor equals 0, because 0 times anything is 0. So here, if this equals 0, I get a critical value. If 7 plus x equals 0, I get a critical value. And if 7/3 x plus 7/3 equals 0, I get a critical value. Well, there's no solutions here, because this is 1 over x to the 2/3 power, and there's nothing you can divide 1 by to make it equal 0. Not even 0, because 1 divided by 0 would be undefined, not 0, so that's a critical value that we took care of up here. 7 plus x equals 0, we'll just subtract 7 from both sides, and you get x equals negative 7. So that's a critical value. I already figured out that x equals 0 is a critical value. And then over here, if you subtract 7/3 from both sides of the equation, you get something like this. And then, I don't know, maybe multiply both sides by 3/7, you get x equals negative 1 for the third and final critical value. All right, second problem. Rather than classify these critical values, I gave you a whole new function and its derivative, because I was afraid that if someone messed up part 1, then you might not be able to get credit for what you could show me in part 2. So in part 2, we're kind of starting fresh. We got this some function g. I don't even bother telling you what the function is, but I tell you that this was its derivative. And what I want you to do is classify all of the critical values using the first derivative test. Well, first, what are the critical values? I think for this one, you can kind of just stare at it and tell that we got critical values when x equals 0, negative 2, and positive 3. Because if x equals 0, this is undefined. Remember, this is the derivative, so the derivative would be undefined. If x equals negative 2, this becomes 0, and 0 times anything is 0. And if x equals 3, this becomes 0. So I have these three critical values, and I want to classify them using the first derivative test. The idea with the first derivative test is you kind of divide your number line up into regions using your critical values as sort of the endpoints of those regions. So if I have 3 critical values here, here, and here, I have 4 regions. And so what I got to do is I have to test each region. So when I'm testing region 1, I take any number that's in region 1. So any x value less than -2. I don't know, maybe x equals -3. And what I got to do is figure out if g prime of -3 is a negative number or a positive number. Well, let's see. If you throw -3 into this first factor, 1 divided by -3 is a negative number. You throw -3 into the second factor, -3 plus 2 is still a negative number. And -3 minus 3 more, that's certainly a negative number. A negative times a negative times a negative is a negative number. So in this first region, my first derivative is negative. Now I'll test region 2. Same basic idea, except now I have to choose a number in region 2. So between -2 and 0, I'll choose -1. Somewhat arbitrarily. I mean, -1 is the only whole number in this region, and I want to make my life as easy as possible. But you could have chosen -1/2 if you felt like it. I just don't know why you'd feel like it. So you take -1 and throw that into the derivative. G prime of -1. 1 divided by -1 is a negative number. -1 plus 2 is a positive number. -1 minus 3 is a negative number. And a negative times a positive times a negative gives me a positive. So in the second region, my first derivative is positive. Now I'm going to test region 3. Any number between 0 and 3. I don't know, 1 maybe? Okay, g prime of 1. 1 over 1 is positive. 1 plus 2 is positive. 1 minus 3 is negative. A positive times a positive times a negative is a negative. Get that my first derivative is negative in region 3. Finally, region 4. Take any number you want in region 4. I don't know, 4 maybe? Let's see, 1 over 4 is a positive number. 4 plus 2 is a positive number. 4 minus 3 is a positive number. A positive times a positive times a positive is a positive. And so what this tells me is, maybe in a different color, so x equals -2. At x equals -2, my first derivative used to be negative and changes to positive. So I must have been at a relative minimum there. And similarly at 3, my first derivative was negative and then it changed positive. So at x equals 3, I also get a relative minimum. However, at x equals 0, my first derivative used to be positive, it was going up, and then it turns around and starts coming back down. So it has this shape, it's got a local maximum, or a relative max, whichever word you want to use. I guess I said relative max up here. So what I get for my answers is this stuff. And then finally, in the last problem, you're given this exact same function g, and you don't know that it's the same function, but it does have the same derivative, g prime of x. So I guess it's not necessarily the same function. It could be shifted up or something, but that won't affect the classification of my critical values. So really all I got to do now is figure out, is confirm these answers, I guess. However, note that because this critical value, maybe I'll write testable, I don't know if that's a word, critical values, are only x equals -2 and 3. I can't test 0 using the second derivative test because 0 was one of the critical values I got where the first derivative is undefined. And if the first derivative is undefined, the second derivative is undefined, so I couldn't get any information about that point using my second derivative test. But I could get information about -2 and 3. Hopefully I'll find that -2 is a relative minimum and 3 is also a relative minimum. The way we do that, well, the second derivative test, as the name kind of implies, is you need to find the second derivative. So g double prime of x. It's just the derivative of this thing. So if you do a product rule, f is 1 over x, so that derivative would be -x to the -2 power. It's because I can think about this as x to the -1. And then leave everything else alone, x plus 2 times x minus 3. And then add to that, leave 1 over x alone, and multiply that by the derivative of my second thing here. Well, my second thing, x plus 2 times x minus 3, is itself a product rule. So I'll have to do another product rule inside this product rule. The derivative of x plus 2 is just 1. And the derivative of x minus 3 is just 1. So what I get as my second derivative is negative x to the negative 2 power times x plus 2 times x minus 3 plus x to the negative 1 power times x minus 3 plus x to the negative 1 power times x plus 2. This huge mess right here. Let's see, I guess you could factor if you really felt like it, but I don't even think I'm going to bother. I'm going to leave this as my second derivative, and all I got to do is figure out what is the sign of this thing when x equals negative 2 and negative 3. So let's see what happens. G double prime of negative 2 would be equal to, well, I don't even have to worry about what this first term ends up being because I got this x plus 2 right here, and when I have a negative 2 in there, that'll make this entire thing 0. So I get 0 plus x to the negative 1 power, so that's 1 over negative 2, times negative 2 minus 3, and then plus this whole thing is going to be 0 also. So you can either calculate this exact value if you want. Negative 2 minus 3 more is negative 5, and 1 over negative 2 will give you negative 5 over negative 2, which is positive 5/2. But really all you care is that this is a positive number. Because it's positive, that means that my function is concave up at that point. And if my function is concave up at a critical value, I kind of have this shape going on. So I must have a local minimum or relative minimum. And I'll do the same analysis, g double prime of 3. Well, same sort of idea. This factor right here will make this entire first term 0. And this factor right here will make the next term 0. So I just got to stare at this thing. Let's see, x to the negative 1 will be 1/3 times 3 plus 2, which is 5. So I get, what, 8/3? But really I don't even care what the number is, just the fact that this is positive. That tells me that x equals 3 is also a relative minimum, which is good news. Because, well, it's good news because now I'm done with the quiz, but also because that matches up with what I found up here. It's nice that you can confirm your answers. So I guess I'll call that good and stop this video here.